In this video, we're just going to do a couple more examples solving compositions of inverse trig functions. So here we're going to have a trig function composed with an inverse trig function that's a different trig function. Okay, so let's look at cosine of sine inverse of negative 1/3. Okay, so the first thing I want to do is let theta be the inside bit. So that's sine inverse of negative 1/3. So that means that sine of theta is equal to negative 1/3. Okay, now remember that the domain, the restricted domain for the sine, restricts it to either quadrant 1 or quadrant 4. And when sine is negative, that happens in quadrant 4. Okay, so we know that it's in quadrant 4. Okay, so we could, instead of using, so we could place our triangle if you want. Okay, so the angle is in quadrant 4, so it's going to be down here somewhere. Okay, so we could make our triangle like this. Okay, where here's theta. And then, so we know that it is, so sine of it, this is the opposite over the hypotenuse. Okay, so the opposite, the hypotenuse is never negative. So that means I'm going to make the hypotenuse 3, and then this you could write as -1, or you could write it as 1 and then just remember that that you're in quadrant 4 later on. So either way, however you'd like to do it. Okay, so now we need to find the length of this side here. So that's going to be the square root of 3 squared minus -1 squared. So that's the square root of 9 minus 1. So it's the square root of 8, which if you simplify is 2 times the square root of 2. Okay, so that's the length of that side. So cosine of sine inverse of negative 1/3 is actually cosine of theta. Okay, and I know that cosine of theta should be the adjacent over the hypotenuse, so that's going to be 2 root 2 over 3. So let me just write that here. This is the adjacent over the hypotenuse. Okay, and because I included the negative, I actually don't need to worry about this, but it is positive since cosine theta is positive when theta is in quadrant 4. Okay, so we don't need to worry about cosine being negative, so it's definitely positive. So let me just write it again. So cosine of sine inverse of negative 1/3 is 2 root 2 divided by 3. Okay, let's try another one. So here I want cotan of tan inverse of negative 1/3. So again, let's let theta be tan inverse of negative 1/3. So that means that tan of theta is negative 1/3. So again, tan being, so tan the domain, so we know that theta here has to be, oops, not square bracket, round bracket. So between pi by 2 and pi by 2, so that's quadrant 1 or 4, okay, just like sine. So in quadrant 1, tan is positive. So because tan here is negative, we know theta is in quadrant 4. Okay. Now again, you could place it in the plane, or you don't have to. So we could just draw a triangle. Okay, just forget about the negative. So if this is theta, then the opposite is 1 and the adjacent is 3. So then the hypotenuse is going to be the square root of 3 squared plus 1 squared. So that's the square root of 10. Okay, that's this side. So then cotan of theta is going to be, so it's 1 over tan, so this is the adjacent over the hypotenuse. Okay, so it should be 3, sorry, not the hypotenuse, the adjacent over the opposite, because it's 1 over tan. Okay, so it's the flip of tan. So this should be 3 over 1. Okay, but theta in quadrant 4 means that cotan theta should be negative. Okay, so we can conclude that cotan of tan inverse of negative 1/3 should be negative 3. Okay, so it needs to be negative because that value is in quadrant 4. Okay, now again, you could have situated the triangle in the plane and then taken into account the negative. That's up to you. Either way is fine. You just want to make sure that you think about whether or not the trig function should be negative in that particular quadrant. So another way we actually could have done this one, because cotan, so let's just write or up here. Because cotan and tan are related, so I could have written this as 1 over tan of tan inverse of negative 1/3. Okay, now negative 1/3 is in the domain of tan inverse, which is all real numbers. So the tan and the tan inverse would cancel. So this would be 1 over negative 1/3, which if I flip the bottom one and multiply also gives me negative 3. Okay, so in the other examples they weren't related, the trig functions that we used. But here we know cotan in terms of tan, so you could actually turn it into tan and then do that method instead. Okay, so that would also work. So those are some examples of solving inverse trig, finding exact values of compositions of inverse trig functions.